don't copy this unless you're super anal. But I'm not going to wait for you to copy it. This is in your textbook. It has like every form, anything that you need to know, any equation formula you need to know for linear equations. So check this out. This one right here looks closest to standard form, which is what you guys are familiar with. The book is calling it the general form, which is fine. Standard form is ax plus by equals c, and all we did is move this constant to the other side. And no, we don't put negative c because it's a constant. It just represents a number. It could be a negative number or a positive number, so you don't need to write that. Then we also have the vertical lines and the horizontal lines. Students always forget these things. It's honestly the easiest lines to remember. Like if you had, let's say you had this vertical line. Oh, whoa, that's way too big. Okay, hold on, I gotta make that smaller. Let's say you had this vertical line right here. What is that? Is that the x equals or the y equals? Okay, which axis is it intersecting? It is intersecting the x-axis. That's how I remember. That one is x equals. Okay, that's this guy right here. If you had a horizontal one, that one is your y equals because it goes to the y-axis. Okay, and it's right there. Okay, review. And then we have you know, your slope-intercept form. He's the most famous. I call him SIF. SIF, yeah. And then we have point-slope form because all you need is a point. See the x1, y1? And you need a slope. That's all you need to write that equation. Point-slope form. I call him Mac Daddy. I call him Mac Daddy because you can get SIF and you can get the general form or standard form using point-slope form. It's the easiest one to build an equation with, which we'll look at in the next video, because we're going to do 2 parts here. Okay, and then the last one, this is interesting. I haven't done this before, but the book took the formula for slope and plugged it in for the m for point slope form. So it's like, bam, there you go. You can technically use this formula right here to get an equation if you don't get a slope, which, I don't know. I think this is too much to remember. I just remember this stuff, everything up here. I don't remember that one. Okay. All right, so let's look at the first one. All I want to do here is graph. I want to graph these 2 linear equations, and you'll notice that they're both in 2 different forms. One of them is in slope, we have 2 forms here. It actually is only in standard form. Actually, let's graph the standard form first. Standard form goes with this guy right here, also known as general form. We're going to write 5x plus 2y equals c. No, not c, equals 12. Okay, and I mean there's different ways to do this. Now, normally if it's in standard form, you want to find the 2 intercepts. The intercepts are the easiest points to find. Do you guys know why?
Because you just cover up one.
Yeah, you can cover stuff up, but why do you cover stuff up? You cover stuff up because you're plugging in a zero. If you're plugging in a 0, it gets rid of it. Like if I wanted to find the x-intercept, I'd plug in 0 for y. So it looked like this. We have 5x plus 2, parentheses, 12. And in there I plug in my 0. And then I get down with it. 2 times 0 is what? 0. So that's why you can cover it up. Quotations, little elementary school tricks. And then we divide both sides by 5. We have x equals 12 over 5. How do I graph that? Make it into a mixed number. Makes it a lot nicer. So we have 2 and 2/5. Okay, and that is what x equals. So that's on our x-axis. So let's put a dot right here. 2 and 2/5 right there. So that's our x-intercept. So that's our x-axis. And now what about the y-intercept? What do I have to plug 0 in for to find the y-intercept? Now you got to plug into x. So we got plus 2y equals 12. I plug the 0 into there, and I get crazy. Peace out, 5. Your mama's ugly. Divide both sides by 2. Y equals 6. And so I go over to 6 on my y-axis, and I go 1, 2, 3, 4, 5, 6. And I put a dot right there. And now all you have to do, once you have 2 points, any 2 points, you can draw a line through it. There's only one unique line that goes through those 2 points. After you do that, you're done. That's how you graph it using intercepts. Now, if you wanted to use slope-intercept form because, he's your BFF and you always want to use him, that's cool. What you do is you have to solve for the y. Get the y alone. You see how the y is alone right there? Get them alone. And so we solve for y by using inverse operations. So I subtract 5x from both sides. I get 2y equals negative 5x plus 12. And then I divide everything by 2. Y equals negative 5 over 2. x plus 6. So I just divided everything by 2, and this is what I got. Squiggly circle. All right. Now, how do we graph using that? Well, you have to know a couple things about slope-intercept form. You have to know that the b is what? The y-intercept. Hence, slope-intercept form. Ah. And then what's the m? Slope. It's a slope, Mr. Patey. It's a slope. All right, so we start right here on 6. 1, 2, 3, 4, 5, 6 on the y-axis. Holy snap, that's like the same thing we got over there. Okay, and then we count the slope. Now, I wrote the negative on the 5. Sometimes the negative, like if it's printed, they'd put the negative in front of the fraction. It would look like this, negative 5 over 2. It would look like that. Well, you could take that negative and you could put it on the 5, or you could put it on the 2. It doesn't matter which one you put the negative on, you'll get the same line. Slope is, you guys remember? Slope is?
Rise over run.
Rise over run. Okay, rise is your 5, or negative 5. If it was a negative 5, do you go up or down?
Down.
Yeah. If it's a positive 5, obviously you go up. Run is your 2. And then if it's a negative 2, where do you go?
To the left.
To the left. Okay. So let's do this one. This one says negative 5, which is down 5, right 2. So down 5, 1, 2, 3, 4, 5, and then right 2. 1, 2. Boom. Looks kind of the same, doesn't it? Same line?
Yeah.
Oh, dang. Good thing I have an undo button. Oh, okay, we'll just live with that line, okay? Now, what if we didn't use that one? What if we use this one? What would it look like? That says up 5, left 2. Is that the same line?
Yeah.
2, 3, 4, 5. 1, 2. Yeah, I put the dot right there, and this line's going to go through it. And so it doesn't matter which one you use. That's the whole reason why I'm showing you guys that. Now, my question is this. Got to put my arrows and say that it's going on forever. Give me a solution to this equation. Like, give me an example. Someone give me a solution to that equation. Let me reword my question since everybody's kind of confused. I got 5, 6. No. Give me a point that's on the line. That's the same question.
Oh.
I know you just said that. I wanted to repeat it because I wanted the video. 2, 1. Let's see. That is 1, 2, and then there's 1. Okay, so that's definitely a dot that I made already when I graphed it, right? That one is definitely a solution. It's 2, 1 is a solution to this equation right here. How do I know? It's on the line. There's another way to know. Do you guys know how? Plug it in. Okay, if I plug in the 2, 1, it goes 5 times 2 plus 2 times 1. Does that give me 12?
Yeah.
Yeah, that would be 10 right there, and that would be 2. That does equal 12. Okay, so it works. Give me another point that is on the line. Yeah? 0, 6. That is definitely on the line. See, check it out. That is 6 is our y-intercept. That is definitely on the line. I'm not even going to check it. We know it's on the line. It's for show on the line. In fact, you can check this one in your head. Check it out. What does the x equal at that point? 0. If I plug 0 in there, peace out fraction, y equals 6. Done. You got it. Good job. 0, 6 is another point that works. Let me write that down. 0, 6. All right, yes, give me another one. Nick.
Negative 4, 4.
Negative 4, 4. Let's see. Negative 4. 1, 2, 3, 4. Up. 1, 2, 3, 4. Dude, that's not even close. Come on.
I say negative 4, 4.
Negative 4, 4?
Yeah.
That's what I did. Negative 4, 4.
Oh, from there. Oh, I thought you meant from.
What do you mean from there? It always starts at the origin.
Oh.
Nobody said this, but they said it last period. They said something like 1. Let's see, what is that? 1, 2, 3, 4. They said 1, 4. That looks like it's on the line, right?
But your line's messed up.
You're right. My line is messed up. It's not perfect. Now, if my line was perfect, you'd be able to tell more easily. But how can I tell for sure if 1, 4 is a solution? You plug it in and see if it works. If it works, it is a solution. If it doesn't, then you know it's not a solution. And this one, I know for a fact, does not work.